All right, we are going to start in on our 2.1 notes. So our new note packet, page 21, section 2.1. First little section there says, is it a polynomial function? If not, why not? So let's understand that there are a few rules to being a polynomial function. First of all, you cannot have a negative exponent. You may not have a fractional exponent. You cannot have an x or a variable, whatever your variable is, no x in the denominator, and no x under a radical. So, basically, if you meet those qualifications, so that's a little bit simplistic, but basically that covers it, you will be a polynomial function. So when I look at my notes, number one, A is not a polynomial function because it has a negative exponent. So that would be a no. B is also a no because it has an x under the radical sign. C would be a yes, because it doesn't break any of the rules. C, in fact, is a linear function. It has y equals mx plus b, basically, so it's all good. D is also all good. It's a quadratic function, x squared. It doesn't break any of these rules. And E is also a polynomial function. Now, be careful. There's a fraction in E, but that's okay. You can't be a fractional exponent, and you can't be a fraction with an x in the denominator. But otherwise, you can be a fraction and be part of a polynomial. Good, done. Know those rules? These are easy questions to answer. All right, number two, write the equation of the linear function given that f of 2 is 3 and f of 4 is 11. Now remember, in function notation, it's f of x. So these two things are just fancy ways of writing ordered pairs. This is the ordered pair 2, 3. F of x, so x is 2. And then y equals 3, 2, 3. And this one is 4, 11. So basically what problem 2a is asking you to do is write the equation of the linear function of the line given these 2 points. So you know the first thing you have to do is find slope. So 11 minus 3, 4 minus 2. I got a slope of 4. Then I'll pick a point. Y minus the y coordinate equals m times x minus the x coordinate. Clean it up a little bit so we can put it in function form. So it looks like y equals 4x minus 5. So as a function then, if I write it in function notation, it would be f of x equals 4x minus 5. And that's the equation of your linear function given those 2 ordered pairs. Now what about B? B is exactly the same thing. What are our ordered pairs? Well, in B, they're negative 2, 0 and 6, 4. So we're going to write the equation of the line. Here we go. Find the slope. 4 minus 0, 6 minus negative 2. I got 1/2. Pick a point, doesn't matter which one. Y minus 0 equals 1/2. X plus 2, x minus negative 2. So y minus 0 equals 1/2 x plus 1. 1/2 times 2. So y equals 1/2 x plus 1. And f of x then written as a linear function, y is the same as f of x. So there you go. Wow, that's pretty easy. Well, speaking of easy, look at the next part. My gosh, we have just spent a whole bunch of time talking about this next part. Y equals -3, x plus 1 squared minus 4. Now, you should know, just by looking at that equation, that that's going to be a parabola. How do we know it's a parabola? Well, it's x squared. And we know that the squaring function is x squared. So, and that's a parabola. So this parabola though, the normal parabola, we know, the BFF that we memorized, is this. This one has been moved. Now, how has it been moved? Well, you know it's been moved 1 unit to the left and down 4. So instead of being vertex at the origin, like a normal one, it is left 1 and down 4. So it is moved to this location. We did this already, I mean, you know this. There's a negative out there in front. Now there's also a 3, and we know that 3 is going to stretch the parabola, in other words, make it skinnier. But for us right now, that's really not important, but it is important that there's a negative in front, because that negative is going to turn it upside down. That's what a negative out in front does. So the directions say, find the vertex, axis of symmetry, and direction of opening. Okay, now the vertex is the turning point, it's right there. So -1, -4. And guys, that came right from the equation. You understand your transformations? That came right from the equation. The axis of symmetry is the crease that if we were to fold our parabola in half, it would be the equation of the crease. So this is the line x equals -1. Your axis of symmetry for a parabola opening up or down, the axis of symmetry will always be x equals, crosses the x-axis, x equals the x-coordinate of the vertex. So your axis of symmetry is x equals -1. And the direction of opening is down. And again, you can tell that right from the original equation. If that coefficient is negative, it's going to open down. If it's not negative, if it's positive, you're going to open up like a normal parabola. All right, how about the next one? We need vertex, axis of symmetry, and direction of opening. I can tell my direction of opening is going to be up because that guy is positive. All right, where's my vertex? Well, stop and think about, you don't need to graph it, but you can if it helps. Stop and think about where this has been moved. Hasn't it been moved 3 units to the right? So its vertex is 3, 0, which means its axis of symmetry is x equals 3. All right, we got another up because that's a positive number. That's all there is to it, positive or negative. Now, where is this one moved? Well, he's been moved 3 units to the left, so -3, and up 10. So his axis of symmetry is x equals -3. Now, I don't know about you, but that's pretty darned easy because we learned all that stuff about transformations, so that is making our life really, really easy right now. Okay. Now, let's come back over and take a quick look at this for a second. The reason that we could just bing, 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 whip through this so easily is because the equation was written in that form. This is called, this form right here, is called the vertex form because it gives you, literally, it gives you the vertex. Left 3, up 10. When an equation is written like this, I'm on 4A now. When an equation is written like this, it's a little bit harder. Now, there are some things you can tell about it already, or one thing for sure. See how that coefficient on the x squared there is negative? That means that my parabola is going to open down. So I can tell that no matter what. I can tell that right from the beginning. But finding the vertex is just much easier when the equation is written in this form. So we're going to transform this equation into that form. And it's not as hard as you might think. But I need you to pay attention step by step. Here we go. So the first thing I'm going to do is add the 3 to the other side. I want you to get rid of this number. We're preparing to complete the square, and we don't want to have that number over there. So add it, whatever it is, add it to the other side. Now, this is the important step here. Take out the negative 2. So that will leave you, factor it out. So that will leave you with x squared minus 2x. And then I want you to put a plus blank in there because you are going to complete the square inside that parentheses. So I pulled out the negative 2. X squared minus 2x, because I factored out a negative 2, plus something. Now I'm going to complete the square, so here I go. Half of 2 is 1, squared is 1. Now I know that's a negative 2, but remember you're squaring, so it's always going to be plus something. So half of 2 is 1, squared is 1. Now, whatever you add to the right, you have to add to the left. I didn't add just a 1 though. See how that 1 is inside a parentheses? And it's getting timesed by negative 2? So I really added a negative 2. So I have to put a negative 2 on that side. When I completed the square, I got a 1. The 1 is inside the parentheses, getting multiplied by a negative 2. So that's really a negative 2 if you distributed it out. Whatever you add extra on this side, you have to add on that side. So now I have y plus 1 equals negative 2. This is a square. That's why we did it. It's a perfect square. And then I'm going to subtract my 1 back to the other side. And there is your vertex form. So you can see that your vertex is right 1, down 1. And if your vertex is x equals, if your x coordinate is 1, then your axis of symmetry has to be x equals 1. All right, if that was a little too much to digest, we're going to do a couple more. It's really easy, one step at a time. Here we go. So the first thing I want you to do is move that 1 to the other side. Now we're going to factor out the half. Now, think about this. You're factoring out a half, so you have to put a number here that when you times it by a half, you get 6. That's a 12. Factoring is basically division, and when you factor out a 1/2, you're dividing a 1/2, which is timesing by 2. Before you get confused, I don't want to hear it. Before you get confused, If I multiply 1/2 times 12, do I get 6? Yes, so that's the right number. So just play around with it. If you can't do it mathematically, if you can't divide by a half, then just play around with it. You have to multiply this times this and get that. And we did. Now, put a blank here because we're going to complete the square. Half of 12 is 6, squared is 36. Half of 12 squared. But be careful, I did add a 36 here, but it's inside a parentheses being times by a half. 1/2 times 36 is 18. So I'm adding an 18 to that side. Remember, whatever you ultimately added over here has to be added over there. So I did 36 inside the parentheses, but times a half, so that's an 18. So I have y plus 17 equals 1/2 x minus 6 squared. I'll move the 17 over. And now I know exactly where my vertex is. My vertex is right 6, down 17. My axis of symmetry is x equals 6, and my direction of opening is up. I could have told that right from the beginning because that 1/2 is positive. All right, one more of these. Now, this one does not have an extra number, so we're going to skip that first step. There's no 1 to move over, so then that's fine. We just don't have anything to move over. We do, however, have to factor out our 3, and we're going to complete the square. So, half of 4 is 2, and 2 squared is 4. Remember, whatever you add to the right, you got to add to the left. But I didn't add a 4, I really added a 12. So it has to get added over here. So I have y plus 12 equals 3, x plus 2 squared. And y equals 3, x plus 2 squared minus 12. Move the 12 back over. And now you can see exactly where your vertex is. Left 2, down 12. Your axis of symmetry is x equals -2, and your direction of opening is up. Okay, so we just did 3 problems where we took an equation that was in, this is called standard form, y equals ax squared plus bx plus c. That's standard form. So our equation was in standard form. We rewrote it in the vertex form by completing the square, and we ended up then with the information that we needed. It turns out that there's another way that you can find the vertex. I'm on 5A now. There's another way. Certainly you could complete the square. That will work always, always, always. Another option is using the axis of symmetry formula. You may have seen this before. X equals -b over 2a. That is a really, really handy thing. And if given a choice, I'm always going to use the formula instead of going through that process. That process is important. We need to know how to do it because there are some problems that can only be done that way. Axis of symmetry formula only works with parabolas. And there are other shapes, like an ellipse or a hyperbola, that we need to have in a form similar to this. So we need to know that process. But if we have a parabola, x squared, quadratic. We can always rely on our axis of symmetry formula to find the axis of symmetry. So the directions are the same. I know I'm opening down. I can tell that just from the original equation. My axis of symmetry, according to the formula, will be negative b. This is the same a, b, and c that you use in the quadratic formula. So ax squared bx c. So x equals negative b, or the opposite of b, over 2a. So my axis of symmetry is x equals 2, which automatically means that my vertex is 2 comma something. Remember, the axis of symmetry and the x-coordinate of the vertex are always the same in a parabola opening up or down. So negative b over 2a gives me that. So now I know my x-coordinate is 2. How can I find my y-coordinate? You're right, just plug it in. So negative 4, this says y equals, right? I'm just going to plug it in. Negative 4 times 2 squared plus 16 times 2 plus 3. Do this in the right order. We square first. So 4 times negative 4, so that's negative 16 plus 32 plus 3. Adding that up, it looks like 19. So my vertex is 2 comma 19. All right, here we go, same thing. We're finding the vertex, axis of symmetry, and direction of opening. We can tell right from the beginning that the direction of opening is up. Nobody's gonna miss that. That's easy. Now, we need to find our axis of symmetry, so we'll use our formula. X equals negative b, or the opposite of b, over 2a. So that's gonna be 6 divided by 2/3, 2 times a third, which is 6 divided by 2/3, which is 6 times 3/2, which is 18 over 2, or 9. So my axis of symmetry, is 9. Which means my x-coordinate of my vertex is also 9. So 1/3 times 9 squared, I'm plugging in now to find y, I'm plugging in. So 1/3 times 9 squared minus 6 times 9 plus 1. 9 squared is 81, and 1/3 of 81 is 27. 81 divided by 3. Minus 54 plus 1. I think that's negative 26. Hopefully my arithmetic is right. I'm not using my calculator, and I could be. I think that's negative 26. So that is my vertex. Now, what we have done so far in this video is we have found the vertex, axis of symmetry, and direction of opening a couple of different ways. If we happen to be lucky enough to have our equation in vertex form, then we can just look at it. If it's not in vertex form, we can either put it in vertex form by completing the square, or we can use our axis of symmetry formula. But one way or the other, given any quadratic function, we will be able to find the vertex, axis of symmetry, and direction of opening. Number 6 is the backwards of that. So in number 6, they are giving you the vertex. They are telling you that the parabola, remember these are quadratics, so they're parabolas, they're telling you that the parabola contains the point 1, 5, and you are going to write the equation of the parabola. Now, when you write the equation of the parabola, you can either write it in standard form, ax squared plus bx plus c, or you can write it in, I'm making these numbers up totally, but the vertex form. Since they gave us the vertex, does it kind of make sense that we know we have x minus 2 squared minus 3? We can start building the equation because we know the parabola has been moved 2 units to the right and down 3. So if you know the vertex, you can really put the nuts and bolts of the equation together. Now, what's missing? Well, remember, we have this coefficient out in front that tells us how skinny or fat our parabola is and whether it opens up or down. And that's a pretty important number. And right now, I don't know what that number is. I know that I've moved 2 right and down 3, but I have no idea what that number is. But I can figure it out. Because whatever that parabola looks like, it must contain this random point. The vertex goes into the equation. This random point is going to help me figure out what that coefficient is. Because if x is 1, then y has to be 5. So in the equation, y is 5 when x is 1. Be careful, make sure you're getting those numbers plugged in the right spot. So x is 5, y is 5 when x is 1. So when I work this out, 1 minus 2 is negative 1, squared is 1. So I have 1n minus 3. So I'll add 3 to the other side, and it looks like n equals 8. So my equation is y equals 8, x minus 2 squared minus 3. Next one, same exact idea, vertex at 5, 1, and contains 0, negative 2. This right here tells you so much. Whatever your equation ends up looking like, we know it's x minus 5 squared plus 1 because the parabola moved 5 to the right and up 1. That is the answer to the question, except for this guy out here that determines the direction of opening and the size of the parabola. So to find that missing number, we will simply take the x and the y that we were given and plug them in. So negative 2 equals something times 0 minus 5 squared plus 1. So negative 2, okay, here we go. 0 minus 5 is negative 5. Squared is 25. So we have 25n plus 1, so we'll subtract 1. And this time our coefficient is negative 3/25. So my answer is y equals negative 3/25, x minus 5 squared plus 1. Just plug in my n value that I got. All right, one more of those, guys. One more. Here we go. This time, we know the vertex -1, -2, and it contains the point -4, 2. Remember, when you build your equation, you gotta start with the vertex. So y equals, it went left 1, down 2. So x plus 1 squared minus 2. This would go left 1 and down 2, which is exactly what our vertex wants. Let's find that missing number, and we'll be done. So here we go. Remember, x and y, get them in the right spots. So 2 equals n times -4 plus 1 squared minus 2. -4 plus 1 is -3. Squared is 9. So we're going to add 2 to the other side, divide, and write our answer. Y equals 4/9, x plus 1 squared minus 2. There you go. We will finish. We have a couple more book problems to do, and then we'll be done with this section. And we'll do those when we're together again. Have a great day.